All right, this experiment is called Candles in a Jar. And what we have here is a pie pan with about 1/2 to 3/4 of an inch of water. We have a little piece of foam holding a candle, and I have a jar. What I'm going to do is I'm going to light the candle, and I'm going to flip the jar over on it, and then you're going to observe what happens. Now, I'd like you to take just a moment and think about what variables are changing and what variables are staying constant if we're using the candle and the jar. Okay. Now we're going to actually conduct the experiment. All right, so I'm going to light one candle. Oh no! All right, there we go. And then I'm going to cover it up and watch what happens when the candle extinguishes. Pay close attention to the bottom of the jar. And watch when I lift the jar off. Okay, so now we're doing the same exact thing, but with 3 candles. If you notice this time, the water rose in the jar almost about 1 inch above, whereas before the water only rose to about the platform of the foam. So now I'd like you to pause the video one more time and think about why the water rose in the jar. Now that you've paused and thought about it for a minute, here's what's happening. Our volume is constant because we essentially have a sealed jar, so the volume cannot change. However, once we cover the candles with the jar, and once they extinguish, it's going from a high temperature to a low temperature, so temperature is dropping. And then because the temperature drops, Guy-Lussac's law says that the pressure will also drop because it's a direct relationship between those variables. So then when the pressure drops inside the jar, that's what the atmospheric pressure is greater than the pressure inside the jar, and that's what forces the water inside the jar.